Okay, guys, this is 10.3.10.4, volume of pyramids and cones. We just finished finding the volume of prisms and cylinders. So now we're going to move on to pyramids and cones, and then also do some word problems that involve finding the volume. So let's go straight to the volume formula, the volume conjecture of a pyramid and a cone. I'm going to just reveal the formula. Okay, the 1/3 capital B times H. And so capital B stands for area of the base, okay? And so it could be anything, any type of polygon for a pyramid, and then it's always going to be a circle for the cone. And then we're going to use H, which that's always going to represent the perpendicular height of the pyramid and the cone, okay? So here's our formula that we're going to use. Let's point it out on some of these figures right here. So right here that I just highlighted in blue, you see that's the perpendicular height. So that's going to be referred to as the H in the formula. And then this is our base. Okay, so it could be any polygon. In this case, it could be a rectangle or maybe even a square. All right, now, but it could be any type of polygon. It could be a hexagon, it could be a triangle, it could be anything. I do want to point out this thing right here. This is from surface area, okay? That is the cursive L, which is the slant height. Notice that is not in our formula here, but it could possibly be given to where you might need to use that to solve for the height, because this shape right here makes what type of shape? A right triangle. So this is the slant height, which we used with surface area, but we could be given that, and we might need to use that to solve for the height, which that's going to get plugged into the formula. Okay, so over here on the cone, you notice the bases are always going to be circles. Okay, your height is going to be right here because it's perpendicular to the base. Over here on this one, remember this one is oblique. Okay, I don't know if you remember that from our last one, but when it's oblique, it's kind of like slanted. So you want to use this perpendicular height out here. Okay, you don't want to use that one right there because that is not perpendicular. And that's pretty much it. Oh, this right here that I just highlighted in green, that is going to be your slant height again, kind of like I just explained with the pyramid. You might need to use that to solve for the height because, again, you have a shape right here that makes a right triangle, and you might have to use Pythagorean theorem to solve for that. All right, so let's go straight to some examples. This first one, we have a pyramid, okay, and the base is a rectangle. It looks like a square, but it's a rectangle because we have 12 and 10 as the length and the width. So first thing I just want to do is I want to write down 1/3 capital B times H. And so 1/3 times area of the base. So remember, the area of the base is a rectangle, so all it is simply 12 times 10. And then times the height, which they simply gave us that too, which is an 8. So we're just going to hit times 10. And so you can always do a little simplifying if you want. 1/3 times 120 times 8. 1/3 of 120 is an easy 40. So you're just simply doing 40 times 8, which comes out to 320 cubic feet. Now remember how to label it. You want to use cubic feet for volume. Over here we have a cone, and the cone is still the same formula. Let's see if I can move this over. 1/3 capital B times H. In this case, capital B is going to be pi r squared. So we're going to do 1/3 pi r squared. If you look at our picture, we notice there is no r given. However, we do have this shape, like we pointed out earlier, which is a right triangle. And the right triangle, we can do Pythagorean theorem. So you want to punch in your calculator, 34 squared minus 23 squared. And then once you get that number, you can take the square root of that. So I'm going to do that right now in the calculator. And we get about 25.04. 25.04. So this is our radius right there. Okay, so we're just going to go ahead and round that. You could leave it in radical form if you like. That's always a good idea, but we'll just go ahead and use a decimal. So we have 1/3 pi. Actually, let's go back and leave it in radical form. That doesn't sound like a bad idea. So 34 squared minus 23 squared is 627. So the square root of 627. So watch when I do this. Square root of 627 squared times the height, which is 23, okay? Because it's always good to label that as the height. Put a little h next to it so you know where to plug it in. So what is the square root of 627 squared? Just 627. So now we're going to do 1/3 times pi times 627 times 23. So the easiest way to do that is just punch in your calculator, 627 times 23, which is 14,421, and then divide that by 3, which is 4,807, and then pi, because I didn't mess with the pi. So what do we have? 4,000, let me pick a different color, 807 pi, and this is in centimeters cubed. Okay, if you want to turn that into a decimal, just multiply 4,807 times pi, and you'll get your decimal. And you can use pi in your calculator. All right, let's go to the next one. This one is a tough one. This one is not quite a cylinder, so you need to think back to section 1 or section 2 when we found a cylinder. It's a portion of a cylinder, so it's kind of like almost taking a slice of a cylindrical cake. Like you take a slice of a cake of that's in the shape of a cylinder. This is pretty much what it is. That's the piece, but it has an angle of 40 degrees. Okay, so it says that the volume is 2,814 meters cubed, but we need to find the radius of what this is. So here's how you want to set up this formula. We're going to do volume equals 1/3 capital B times H. Actually, no, not capital B, not 1/3. Because 1/3 is only 4 1/3 is only 4 cylinders. I mean, cones. So we're going to do, for the base, it's actually here. Let me outline the base. The base is a sector. And so I don't know if y'all remember how to find the area of a sector, but that's what this is right here. And so if you can recall that, it's x over 360 times pi r squared times the height. Okay, and that is going to be our volume. Now we know our volume, it's 2814. So I'm going to plug that in for V. I know what X is. X is 40 degrees out of 360 times pi. We're going to solve for the R, so we don't know what that is. And we know the height of this cylinder is 14. So at this point right here, it becomes algebra. Okay, so we're going to start solving it algebraically. I'm going to go ahead and switch a color so you can see what I'm doing next. I'm going to reduce this fraction right here. I'm going to cancel out the zeros, and this actually reduces to 1/9 pi r squared times 14. 2814. Now, what some of y'all probably would do is y'all would probably, since this is all being multiplied, you can divide by 14, and that'll cancel out. So I'm going to divide both sides by 14. 2,814 divided by 14 is 201. Okay, and so all I did was copy what I have left. So I have 1/9 pi r squared equals 201. How do you get rid of the 1/9? Well, you want to go ahead and multiply by 9 to get rid of that. Whatever you do to one side, you have to do to the other. So I'm going to multiply that by 9. So 201 times 9 is 1,809 equals pi r squared. We're getting closer to getting r by itself. The next step would be to divide by pi to get rid of that. So 1809 divided by pi in the calculator is 575.8226. And that is equal to r squared. And what's the last step? To square root that whole thing to get rid of that. And so r is by itself. And now all I have to do is hit square root in my calculator. So this is about 23,996. So if we were to round to the tenths or the hundredths, we could say the radius is about 24. And there we go. So the radius is 24. So that's a tough one. You had to figure out what capital B represented. And in this case, capital B was a sector. So maybe we should write that down. This was a sector. So you had to remember how to find the area of a sector. Okay, that's a tough one. Let's move on to the next. Another word problem. It says a child's wading pool has a diameter of 7 feet and is 8 inches deep. So the height of that is 8 inches. And so that I drew on there for you. How many gallons of water can the pool hold? Round your answer to the nearest 0.1 gallon. So we're going to round to the tenths place. And then water weighs about 63 pounds per cubic foot, and a cubic foot of water is about 7.5 gallons. So I need to go highlight what it is that we're trying to find. Okay, so it says how many gallons of water can the pool hold? That's all we're looking for. How many gallons can it hold? And then they gave us some information down on the bottom. So what I need to solve for first is the volume. So let me get my pen and let's find the volume. So remember, volume is capital B times H because this is like a cylinder. Okay, see there's your circle, there's your height, and then there's the circle on the bottom. So this is a cylinder, so it's capital B times H. This is from the section from before. Pi r squared is always going to be my base for the cylinder. Okay, and it says that R is, or I should say the diameter all the way across from there to there is 7 feet. Okay, now you got to take a good note here that that's 8 inches and this is 7 feet. Okay, so our radius, which is halfway, that's going to be 3.5 feet. So we need to figure out what this is in feet, okay, because we don't really want to use inches. How do you turn inches into feet? It's pretty simple. You just divide it by 12, okay? So that reduces to 2/3. So 2/3 feet is the height of that. And the reason why we want to turn it to feet, because if you read right here, let me get my highlighter, it says a cubic foot of water is about 7.5 gallons. Okay, so 1 cubic foot of water is about 7.5 gallons. So that's why we want to have it in feet. We really don't want to put it in inches and convert at the end. Okay, so we want to put it all in feet. So 2/3 is what we're going to have to work with. And it's okay that it's a fraction. We're just going to work through it. So we got pi 3.5 5 squared, okay, because that's what the radius is, times 2/3. Okay, and that's okay. Just you can put it as a fraction, and you can put that in your calculator as well. So pi times so pi times 3.5 squared times 2/3 is about, and I'm just going to go ahead and give the decimal because we're going to use an estimate. When I put that all in a calculator, we get about 25.656 cubic feet. So that's how much volume is in that little pool. So the question is, it says how many gallons though, because remember we highlighted how many gallons. So what do we want to multiply this cubic feet by? By 7.5 gallons, and then it'll turn it in to however many gallons that is. So when I multiply that, then I get my final answer to be about 192.4 gallons. Okay, so again, using the volume formula and then making sure we convert the units to what we need it to be converted to. Okay, let's try last two problems. These are pretty challenging because we want to tie in the algebra because you're going to go into Algebra 2 next year. So this first one is a cylinder, and they give us the radius to be 2x, and they give us the height. So remember, the height goes from base to base, and it's okay to go from left to right. And so we're going to plug that in there. So what's my formula? Volume equals capital B times H, which capital B is pi r squared. So we want to use parentheses in this to make sure that you do it right. So the parentheses here for r is 2x, and you want to make sure you square that. And then the height is 3x squared minus 12. So here's where your algebra skills need to come into play. 2x squared means the same thing as 2x times 2x, which 2 times 2 is 4, and x times x is x squared. So we have pi 4x squared times 3x squared minus 12. And so this property right here, you need to remember, is the distributive property. So we're going to distribute that out. And you can use pi as well. Okay, so it's like saying 4 pi x squared. So here, I'll rewrite it so you can see. It's 4 pi x squared. You can rotate those around because those are all being multiplied, times 3x squared minus 12. So now let's distribute here. So what is 4 pi x squared times 3x squared? 12 pi. What's x squared times x squared? X to the 4th. Remember, you have to add the exponents. So 12 pi x to the 4th minus, because we have a minus right there, because now we're going to multiply this times that. And 12 times 4 is 48 pi, and then x squared. We don't have any x terms on that last one. And so here's my final answer in algebraic form of the volume of this. Okay? I'm not going to rewrite it, so we can just leave it like that. All right, and then this last one, we have a pyramid, and the base is a pentagon. And when it has this thing right here that I highlight in red, that is called the apothem. So this is a regular pentagon, so we're going to have to use that. Formula. First thing we got to do is write down the correct formula. So let me see if I can slide this over here. So I can start up top. Okay, so our formula for this is going to be 1/3. This is where kids often forget that. 1/3 capital B times H. 1/3, what did we just say the base was? A regular pentagon. That's 1/2 apothem times perimeter. And then we have times H. So we have to insert the correct formula for capital B. I'm going to go ahead and simplify that. 1/3 and 1/2 make 1/6. You can multiply that out. And then we have the apothem, which the apothem is x. And then the perimeter, okay, so the perimeter, we might have to go over here off to the side and do the perimeter off to the side. So if this is the side length, we want to multiply that times 5, right? So 5 times that is 5x squared minus 20x. Okay, so let's go ahead and plug that in. 5x squared minus 20x. And then the height is 10x. Oh no. Oh, Lordy. Oh my gosh. Just gonna write it underneath. Okay, so now it's time to do the simplifying. So best thing that I would probably want to simplify first is I'm going to distribute the 10x over here. Okay, so the 10x, and I know it looks weird on how I'm going from right to left, but to me that would be the easiest way. So I have 16x, and then on here, what's 10x times 5x squared? That would be 50x cubed. And then what's 10x times negative 20x? So that would be negative 200x squared. Okay? And so then we just have one last thing to do, and that's to multiply, make it a different color, this 1/6 times those two things there. So 1/6 times 50x cubed is 50 over 6 x to the 4th. And you can do 1/6 times 50 or 50 divided by 6 in your calculator. We'll change that here in a second. Minus 200 divided by 6 x to the 3rd. And so what is 50 divided by 6? If you want to turn it into a decimal, you can do 50 divided by 6. And so this is about 8 1/3. It's 0.33 repeating, but I'm going to leave it like that. X to the 4th minus, what's 200 divided by 6? 33 1/3. X to the 3rd. And so there's my final answer for the volume of that pyramid. And again, you can put it in decimal. You can write 8 point if it makes you feel better. Do this. That's another option. Okay, remember, that's just an estimate. Okay, so that's volume of pyramids and cones, a little bit more challenging with the algebra. And that is it.